9 to the n times x to the n. And that 9 to the n times 2 to the n is 18 to the n. So far, so good. And so this is the stage where we have 1 plus square root of 1 plus x to the 9. What was the next step? Yes, we want to multiply by 3. This 3 and the square root of 9. So we have square root of 9 plus x. I mean, what do we want the power series for? Square root of 9 plus x. Last step. Minus 3. Subtract 3 from both sides. The second part of the question wanted us to approximate square root of 9 plus n. So what's the x value? I'm going to plug in and make this happen. So I'll plug in x equals 0.1 here. And I'm going to write this out by hand. You'll see why in a minute. So if I plug in n equals 2, that's a negative 1 over 18 squared, 2 factorial times 3, 0.1 squared. Next one is plus 1 times 3 over 18 cubed, 3 factorial times 3, 0.1 cubed, minus 1.5, 18 to the 4th, oops, it was 4 factorial. And what I see here, I'm happy about, is this is an alternating series. And how do I do an error analysis for an alternating series? Good. I want to find the first unused term. Oh, and 5 decimal places means the error is smaller than 5 decimal places, its error is smaller than 0.50. Those numbers are getting small quickly. I did the calculations for you. You're going to use so what I got is the numbers aren't exactly going to be right. But roughly this is 0.003, say, and this is 0. I know exactly what those numbers are, but that's the idea that'll come out. When you plug in n equals 2, it's still too big. When you plug in n equals 3, that's the first term that ends up smaller than what we're looking for. So do I use this one? No, because that's the first unused term. So I can get 5 places of accuracy just from the first 2 terms of that series. What does B say? Oh, good point. Okay, so everybody with me on C? Oh, radius of convergence, that's actually interesting. What test do I use if I have one of those funny factorials? Ratio test. So ratio test always works. I always think it's more work to write it out. The root test just seems like it's easier to write. This one, we are going to need the ratio test. And remember how for the 1 over 1 minus u identity, we had, it was fairly easy to find the radius or the interval of convergence, just we knew what u were. This is very sensitive, the binomial series expansion is very sensitive on what the r is. So if you're interested, you can go to Wikipedia, it has a nice write-up about given r, how to know what the radius of convergence is. But we're going to do this by hand. Ratio test is we look at a sub n plus 1 times 1 over a sub n. Do that with the funny factorials. So first of all, I'm taking an absolute value. I can ignore the alternator. Here's the n part. These go by 2 each time. So the next one is 2n minus 1. The denominator is 18 to the n plus 1 times n plus 1 factorial x to the n plus 1. Then if I turn this upside down, it's 18 to the n factorial. Looks like. We'll erase this part. You're copying that down. Luckily, there's going to be a lot of simplification there. So that's the easy part. Those are going to come up. Notice I've got n 18s on the top, and I've got n and 1 extra 1 on the bottom. So this is simplified to an 18. And if I have an n factorial on the top and an n plus 1 factorial on the bottom, How do those simplify? N plus 1. And then finally, x to the n plus 1 over x to the n. What do I get here? Let's just rewrite this. Limit n goes to infinity. On the top, we've got a 2n minus 1. We've got an x. On the bottom, we've got an 18. And n plus 1. Do I have it all? And then finally, it's, now the n goes to infinity. Actually, let me write it this way. You might have to remember this. You talked about this in your Calc 1 class. Is the dominant term, so the dominant term for 2n minus 1 is 2n. So just keep the 2n. The dominant term for n plus 1 is n. Or the idea is n's going out to infinity. So n's a big number. So n plus 1 is essentially the same thing.